Ah, electric scooters. The last mile transportation option nobody asked for or really wanted, but nevertheless came out of nowhere to transport drunk people around our cities. Love them or hate them, for now at least, it seems like they're here to stay. Lime, the company that builds the green scooters, wanted to offer dockless transportation options that people can unlock with their smartphones and use GPS to locate the closest device to them. In order to transmit their GPS location, scooters can connect to wireless networks to transmit small amounts of data that can tell the company where the scooters are located and how much battery life they have left so they can pass this information on to their customers. Electric scooters are just one of the many devices that fall under the category of Internet of Things, usually abbreviated to just IoT. IoT sensors are low-cost, long battery life tools that are helping to shift more of our physical devices into the digital world by connecting everything to the internet. The IoT device market is growing rapidly. Some estimates project the number of IoT-connected devices to grow at around 20% annually over the coming decade, to reach an estimated 25 billion devices by the year 2030. There are basically three trade-offs when it comes to wireless telecommunications: bandwidth, how much data a device can transmit; range, how far a device can transmit data; and power consumption, how long a device can remain available to transmit data. Cell phones can transmit a large amount of data over a medium range with high power consumption, as most devices need to be recharged after a day of use. Wi-Fi can transmit large amounts of data over a short distance, while typically being plugged into a continuous power source. IoT devices fill the niche of low data transmission over a long range using very little power. Cell towers were built to handle the wireless communications of things like telephones and radios. IoT devices, which often need to rely on just a battery to keep it online for weeks or months at a time, cannot directly use this infrastructure efficiently. Enter Helium, an open-source distributed network of hotspots that was built to address this market. Helium uses the LoRaWAN standard to connect IoT-enabled devices to the internet. LoRaWAN is a protocol built to operate a low-power, long-range, wide-area network. Helium is attempting to build a wireless network completely from the ground up, without relying on the expensive infrastructure typically needed by internet service providers like Verizon and AT&T. To do this, they're using a novel incentive mechanism enabled by cryptocurrencies. Let's explore how they plan to accomplish this. Amir Halim spent most of his early career in the video game industry. While in college, he played Quake professionally, and after graduating, he went on to join a team at DICE that built Battlefield 1942. Around 2012, he met Napster co-founder Sean Fanning, and they got to talking about how there wasn't a wireless network built for low-power sensors like tracking devices or air quality monitors. They took this idea and decided to run with it, founding a project they called Helium in 2013. Amir and team struggled for a bit to get this project off the ground because they couldn't decide how they were going to deploy the infrastructure necessary for operating the network. ISPs like Verizon and AT&T spend billions of dollars building cell towers and buying spectrum that allows them to operate cellular networks. This is an impossible strategy for any startup to mimic because the capital requirements are enormous. After studying how Bitcoin and other cryptocurrencies operate, they thought this model could help incentivize users to build the network alongside them, while giving users ownership in the growing network so they could participate in any financial rewards the network received. Little did they know that this would be the key tipping point to unlocking this huge opportunity. Since launching the Helium blockchain on July 29, 2019, the network has grown to host over 800,000 active hotspots in 170 countries around the world in just 3 short years. Let's dive into the weeds briefly to see how the Helium network operates. Helium tries to make it as easy as possible for anyone to set up a hotspot and participate in the network. All someone has to do to start is buy a Helium-approved hotspot, plug it into an outlet, and connect it to their home's Wi-Fi network to start earning Helium rewards. At first, Helium was the only hotspot manufacturer, which led to a supply bottleneck, but they have since open-sourced the hardware specs, which enables manufacturers around the world to sell the hotspot equipment. Hotspots cover a range up to 100 miles away. However, users in cities where there are lots of signal interference may find that their device only covers about a square mile. Helium hotspots run a unique consensus mechanism called proof of coverage. The purpose of this algorithm is to verify that hotspots are constantly available on the network and that they aren't lying about their location or status. You may have heard of other consensus mechanisms like proof of work, which Bitcoin uses to secure its network, or proof of stake, which Ethereum is currently transitioning to. Part of the rewards that hotspot owners receive comes from successfully passing the proof of coverage challenges. The key purpose of the network is to transmit IoT device data So the main way hotspot owners should receive rewards is by transmitting data. However, this is not the case yet, as we will see in a moment. All data transmitted by the network is encrypted, so hotspot owners can never dissect the traffic they are relaying. Both hotspot owners and IoT device owners use Helium's native token, HNT. Devices that want to pay for data transmission need HNT to transmit their packets, and a portion of this fee goes to the hotspot owners that relay this data to its final destination. Hotspot owners receive HNT rewards from data transmission and proof of coverage challenges. To use the Helium network to transmit data, IoT device owners need to purchase some Helium tokens at the market price, which are automatically converted to data credits when used. The HNT token has a maximum supply of 223 million tokens. A recent Helium governance proposal, HIP 20, introduced net emissions, which adds burned tokens spent on data credits back into the network to help keep the supply and demand of HNT balanced. The net emissions do not add to the max supply of HNT. They can only be created at the same rate they are burned, so the network never runs out of HNT to use. Data credits have a fixed rate of 100,000 data credits per $1 spent. One data credit covers 24 bytes of information. As a rough example, 1 megabyte equals 1 million bytes. So it would cost around 42,000 data credits, which would be about 42 cents, to transmit 1 megabyte. The LoRaWAN protocol that Helium utilizes for IoT devices operates in the unlicensed portion of the radio spectrum allocated to wireless communications by the FCC, at least here in the United States. Telcos bid on and buy portions of the licensed spectrum where they are allowed to operate their cellular networks and TV broadcasts at specific frequencies and in certain geographies. A portion of the spectrum is left unlicensed where it is free for anyone to use and is perfectly suited to low data use applications like IoT devices. Okay, now that we know how the network operates, let's look at the main question. Is the Helium network actually being used? There's clearly interest from people wanting to use hotspots to earn rewards from the network, as the number of hotspots connected to Helium's network has gone exponential from less than 15,000 hotspots at the start of 2021 to over 800,000 hotspots here in 2022. Looking at Helium's Block Explorer, we can see that over 300 billion data credits have been spent in the last 30 days. That results in around $3 million, which is pretty impressive. When we look at the breakdown of data credit usage, however, we can see that nearly all of the data credits getting spent on the network are coming from adding new hotspots, represented by the blue lines, and completing proof of coverage challenges, represented by the purple lines, not from data transmission, the tiny blue lines at the bottom. In many ways, this makes sense. IoT devices transmit minuscule amounts of data, which even with an enormous amount of demand, may not result in much of a reward for hotspot owners. Helium is also at the early stages of growing their network, so they are doing their part to reward users for deploying network infrastructure. Seeing that most of the rewards are not coming from actually using the network is a bit concerning though. The sustainability of Helium's network will rely largely on manifesting demand for IoT data transmission, not just from paying people to connect to Helium hotspots. There's kind of a chicken and the egg problem here with what comes first. The infrastructure needs to be there before people can use the network, but people need to be incentivized to build out the network so that it can be used. Helium has already been successful in expanding their network globally. Perhaps other entrepreneurs will come up with useful applications that Helium is uniquely positioned to serve. For example, Lime scooters did not exist a few years ago, and now they are ubiquitous in cities around the world. At this point, though, we'll have to wait and see how much demand can materialize for IoT data transmission. It will need to increase significantly in order for the network to remain sustainable. The main competitor to Helium is a project called the Things Network. The Things Network was started around the same time as Helium, having been founded in 2015 to serve IoT device owners and hotspot hobbyists. It operates in a pretty similar manner to Helium, using the LoRaWAN standard to transmit IoT device data over a crowdsourced network. It also operates in an open source manner, allowing anyone to build on top of the network. There's one major difference though. The cost to transmit data on the Things Network is free. Yes, free. Like we've already mentioned, IoT devices use hardly any data. Even with the exponential growth in these devices over the coming years, it is yet to be seen whether the demand for data will actually lead to anything material financially. Of course, using the cryptocurrency incentive model has helped Helium scale a lot larger and faster than the Things Network, but scale means nothing if demand never reaches maturity. Helium does not plan on limiting their aspirations to just supporting IoT devices, though. Right now, Helium's team is focused on expanding the current network. The number of hardware manufacturers that are approved to build the open source hotspots are increasing, as are the number of sensors and use cases that can run off the network. However, Helium's larger goal is to become the blueprint for how open, affordable, and secure global wireless networks are built. The Helium community is in the process of discussing how to add 5G support to the network. Governance proposal HIP 51 has been submitted and approved to start scaling Helium into a network of networks. Now, this is where things really start to get interesting. Dish Networks has been the first traditional telco company to sign on to help accelerate Helium's 5G ambitions. The model will likely look similar to Helium today, where users can buy and deploy hotspots at their home or office and earn rewards for providing short-range 5G coverage to users around them in the form of HNT. As the number of networks expands under the Helium community, new tokens and governance structures will need to be set up to manage them independently, while still keeping the data credit usage under the Helium umbrella, so rewards accrue to the core HNT token. IoT is a fascinating use case to start with, as it is already an underserved market in the telecommunications industry. But if Helium can be anywhere near as successful in deploying 5G hotspots as they have been with their LoRaWAN hotspots, it will really change the landscape for how future wireless networks are built and deployed. The main risk facing Helium right now is that they are highly reliant on the goodwill of telcos. Because Helium hotspots piggyback off of telco-supported routers, any move on their part to block Helium's service could potentially knock the network offline. Many ISPs would have to coordinate to do this, but it would not be unheard of. This may not be a big issue if Helium sticks to building LoRaWAN infrastructure, but their pivot to 5G could increase tensions. Another risk to Helium's success is simply providing a network that people find value in. Of course, we can already see that some users find the network valuable, but if the hotspot mining rewards were to fall to make it not worthwhile to add new hotspots to the network, or keep existing devices connected, this could significantly hinder the growth of the network. IoT device volume needs to be high enough to support miners' investments. Hopefully, with the addition of 5G support, this will bring a much higher demand for data to Helium, but right now this is just theoretical. Then there is network congestion, something all networks have to deal with eventually. Denial of service attacks, gossip network usage, and slow block times can all contribute to making the network unusable and slow, which means devices don't work as intended and miners don't receive the revenue they were expecting. Helium has taken an extremely interesting approach to building a wireless network from scratch. It goes to show how incentivizing participants at every level of the network can help grow network scale massively in a short period of time. Although the jury is still out on whether or not IoT device demand will provide enough revenue to hotspot owners to stabilize the network, the Helium community is already looking ahead to the new opportunities additional wireless networks like 5G can bring. Helium is one of my favorite examples of how cryptocurrencies and blockchains can bring new incentive models to real-world applications. I am excited to watch Helium continue to grow and mature, and I will be rooting for their success every step of the way. Thank you for watching.